1.3, real numbers in the number line. Let's look at the solve it. If the pattern continues, which will be the first figure to contain more than 200 square units? Explain your reasoning. See, at 1, there's only 1 square. 2, there are 4 squares. 3, there are 9 squares. And 4, there are 16 squares. So which ones to contain more than 200 square units? Also, think about, can you have a square that has 200 square units? Because if you look, this is 1, 4, 9, and 16. So take a look at that. So keep on thinking about that in the back of your mind as we roll into looking at square roots, perfect squares, radicans, radicals. All right, so problem 1. What is the simplified form of each expression? So 1a, radical. Now, this can be pronounced as root 81, square root of 81, or radical 81. You will hear me say radical, and very rarely will you hear me say root. So, all right, now that we looked at that, we want to simplify form of each expression, the square root of 81. So what same two numbers can you multiply together that will give you 81? Answer is 9, because 9 times 9 will give you 81. All right, so if we look at one more, so if we look at 1b, now we're doing radical 9 over 16. Now, as we go into later, there is a property where you can take the square root individually of each one. Square root of 9, what two numbers can multiply together? What same two numbers can multiply together to get 9, which is 3? What same two numbers can you multiply together to get 16, which is 4? So your answer is 3/4. So why don't you try the got it and try letter A, radical 64, and letter C, radical 1 over 36. All right. Moving on to problem 2. Lobster eyes are made of tiny square regions. Under a microscope, the surface of the eye looks like graph paper. A scientist measures the area of one of the squares to be 386 square microns. What is the approximate length of the square to the nearest micron? Now, there's 2 ways you can do this. So, what do we want to know? We want to know the approximate length of the square to the nearest micron. So that means that this square here, the area of one of the squares is 386 square microns. So I'm just going to label it like that. That means that this side and this side are the same. So I'm going to label them X. So that means that X times X will give me 386. So, or roughly 386. So, first method, let's estimate by finding 2 of the closest perfect squares to 386. Now we know that 20 squared equals 400. So, let's look at the square below it, 19 squared, which is 361. If you look at that, 386 is between both of them. So, because 386 is closer to 400, we can approximate that the square root of 386 is roughly 20. So therefore, that is approximating the side length, 20 microns. Or, which is a way that you guys would probably like, method 2, is using a calculator. So, either on your TI-83 or TI-84, or if you have a different calculator, you can estimate by putting the square root of 386. And that gives you roughly 19.6, which when you round up will give you 20 microns. So if you don't have a calculator, it's probably better to use the first method. But if you do have the calculator, it's much faster and much more efficient. So, why don't you try the got it for number 2, and it is, what is the value of 34 to the nearest integer? Now remember, integer is any positive or negative whole number. Alright, so if you look at your notes that I gave you, you can see that there's a real number, rational number, irrational, integers, whole, and natural. If you flip the page, as I will go in tomorrow, it will tell you the subsets of everything. We'll go into more depth in it tomorrow. So why don't we look at problem 3? All right, problem 3A. So to which subsets of the real number does each number belong to? So you start with the real numbers, and every other set is a subset of them. So let's look at 15. Well, 15 is a natural number because it's any positive whole number, including 0. It's also a whole number. It's also an integer because it's a positive whole number. And it's also rational because it can be written as a fraction, and its decimal terminates. Rational. So let's look at letter B. Negative 1.4583. First, let's look at the bottom. It's not natural because it's not a positive whole number, and it's not a whole number because there's a decimal. It's not an integer because it's not a whole number. It is not irrational because the decimal terminates. It ends. So, it is a rational number because the decimal ends. All right, and let's look at problem C, radical 57. Now, what we went through is radical 57 a perfect square? It is not. So, therefore, because it's not a perfect square, it cannot be written as a fraction, and its decimal does not terminate, nor does it repeat with a pattern. So, therefore, if it's not rational, this number is going to be irrational. And if you look on the flip side of your paper, if it's rational, there could be all these possibilities as an integer, whole, or natural number. However, if it's irrational, there's no other subset it can belong to. It can only belong to rational. So on your got it, why don't you try the subsets for radical 9 and letter C, negative 0.45. All right, moving on to problem 4. So an inequality. An inequality is a mathematical sentence that compares the values of two expressions with a less than or equal to, a greater than, or a greater than or equal to. So it is not an equation. It compares two expressions. All right, so problem 4 asks, what is an inequality that compares the numbers radical 17 and 4 1/3? So let's evaluate radical 17. That's approximately 4.12310. 4 1/3 as a decimal is 4.3 repeating. So when comparing, first what we want to do, the first step is to put them in decimals, because it's a lot easier for me to look at because I don't know radical 17 off the top of my head. So first we put it in decimals, right? That's our first step. So our second step now is to compare. 4.123 is less than 4.3 repeating. So therefore we can write radical 17 is less than 4 1/3. Or conversely, 4.3 repeating is greater than 4.12310. So we could write 4 1/3 is greater than radical 17. So why don't you try to got it for, write a mathematical inequality for radical 29 and 129 and 11.52. Looking at problem 5, we want to know what is the order of radical 4.4 negative 2/3, radical 2, and negative 1.5. From least to greatest. So first what we did is we put everything into decimals and or whole numbers. So radical 4 is 2 because it's a perfect square. Negative 2/3 is negative 0.67. Radical 2 is 1.41 approximately. So now that we've looked at that, and we also have 0.4 and negative 1.5. When we order from least to greatest, we want to know what's the smallest number, negative 1.5. What's the next smallest number? Negative 6.7. What's the next number? 0.4. Then radical 2. And then radical 4. So that is from least to greatest. So why don't you try to got it and order this from least to greatest, 3.5, negative 2.1, radical 9, 7/2, and radical 5.